Well, hi, welcome back, Dartmouth family. Let's go ahead and finish up physical and chemical properties of matter and physical and chemical changes. Okay, so how can they be useful? We know that matter has a ton of properties. We can also call them characteristics. Um, the density, magnetism, melting point, boiling point, whether or not something conducts heat and electricity. Um, but those characteristics can be used to help us identify unknown substances. So for instance, if we know that tin has a melting point of 232 and lead has a melting point of 327, if we have two samples and we don't know what they are, we could certainly try melting. And then depending on which one melts at 232, we would know which one is tin. So why else are they useful? Okay, we know that we have two types of properties. We have physical properties and we have chemical properties. And since we've learned that the properties are the same for a given substance, they do not change. It doesn't matter how much or the amount of sample that we have, then we can use them to compare and classify matter. So those physical properties, those things that a substance has that can be observed without changing the identity or changing it into something else. How shiny something is, how hard it is, if it is magnetic, if it can dissolve in water, or how soluble it is, the melting point, the boiling point, freezing point, condensation. And so all of those things are independent of the amount of substance that we have, and those are all physical properties. We can observe them, but we are not changing the identity of that substance. Versus chemical properties. Some properties of matter can't be seen or identified by touch. And what those chemical properties do for us is they describe the ability to change into different substances. And again, those same types of properties can help us classify substances. So, physical or chemical, rusting, flammability, magnetism, whether or not it conducts electricity, tarnishing, melting. You try. Okay, so how does matter change? When a substance undergoes a physical change, it's still the same substance after the change. But again, when a substance is undergoing a chemical change, now we are getting something new, something different. Those changes are important because it's those changes that produce all of the different compounds that we encounter in the world. When the appearance or form of a substance has changed, but no new substance is produced, then of course we know that that is a physical change. Of course, changes in state are physical changes. Vaporization, condensation, melting, freezing, sublimation, deposition. But a change in matter that produces one or more new substances is a chemical change, and that happens through a chemical reaction. Now, chemical reactions can break down a substance into two or more substances, or we can actually use a reaction to combine substances to make a new one. Everything you encounter in the world around us is made up of some kind of combination of elements. And it could be that those elements have possibly formed compounds of a result of a chemical reaction, or maybe have been broken down from something larger. And so some examples of chemical changes: combustion. So from combustion, from burning, we are producing heat and light and new substances. Electrolysis, using electricity to break a compound into elements or simpler compounds. Oxidation, combining a substance with oxygen. That's what happens when something is rusting. Tarnishing, It's a combination of a bright metal with sulfur. And what we get from that is a dark coating on the metal. Brass does that. So now you try. Chemical or physical change. Tearing paper. It's physical. Mixing salt and water. Physical. Burning paper. Chemical. Evaporating salt water. Physical. Mixing vinegar and baking soda. Chemical. Okay, again, just a brief overview again of physical and chemical properties of matter and physical and chemical changes. Talk to you soon.